All right, in class today, which was Tuesday, we first did molarity notes, and now we're going to do some practice problems. In class, we defined the following words: concentration, dilute, concentrated, and molarity. So I'm going to pause the video, and I'm going to write in the definitions so that you don't have to wait, and you can just see the definitions as they're written down. All right, so these are the notes that we took in class. You can read them for yourselves. I won't read them for you. I do want to draw your attention to molarity. So the formula for molarity, which is the concentration of a solution, is you're going to put the number of moles of the solute over 1 liter of the solvent. So let's go ahead and work out this first problem. And in this case, we want to calculate the molarity of a solution if there's 1.5 moles of NaCl in a 2.3 liter of solution. Well, the first thing when I notice when I look at this is I have to calculate the molarity. I have to calculate that conversion factor. It's giving me moles, which is going to be my known. It's giving me liters, which is going to be my known. So all I have to do is plug these numbers into the formula for molarity. So number of moles over 1 liter of solution. In this case, it'll be equal to 1.5 moles over 2.3 liters of my solution. When I put that in the calculator, and the molarity of this solution is going to be 0.65, and it's going to be a capital M for molarity. I need two significant figures because 0.15 has two significant figures, and 2.3 has two significant figures. So I'm going to need two significant figures in that answer. Let's go up to the next one. How many moles of sucrose would be in 8.7 liters of a 1.1 molarity solution of sucrose? Well, here I've got my conversion factor. When I see that 1.1 with a capital M, that 1.1 is going to be moles per 1 liter of my solution. So that's my conversion factor. I look back in my question and I see that I've got 8.7 liters. That becomes my known. And how many moles is my unknown. So this is a factor label problem. Draw my table, 8.7 liters. If I have liters on the top, I'm going to need liters on the bottom. I'm going to use this conversion factor. 1 liter is going to cancel off the liter that's on the top. 1.1 moles is what that conversion factor is telling me. So I'm ready for my calculator. I put that in and I get 9.57 in the calculator. This has two significant figures. This has two significant figures. So I need two significant figures in my answer. So I'm going to round that to 9.6 moles. And that would be my final answer. Let's go on to number 4. How many liters of a 0.225 molarity solution of Ki are needed to contain 0.935 moles of Ki? So I'm going to look at my question and see if I can find the conversion factor. I'm looking for that capital M. There it is. So 0.225 moles in 1 liter of solution. Now I can look through, find my known. Here's the other number that's there. And how many liters would be my unknown. Now for my table. 0.935 moles is my known. And now I'm going to go up and I'm going to look to see where do I have moles. Well, I've got it right here. But in order to have my units match up, I'm going to have to flip my conversion factor there so that moles is on the bottom. 0.225 moles per 1 liter of solution. Now I'm not done yet, or yes I am. because I need to end at liters. So now I'm ready for the calculator. I put that in the calculator, and I'm going to find the answer is 4.16 liters. I need to have 3 significant figures because there's 3 and there's 3. I've got 3 significant figures in my answer, so it's good to go, just the way it is. It's perfect. Number 5. Number 5. You're alive because there's number 5. Going to scan the question, see if I can find a conversion factor. Oop, there it is. Oop, there it is. 0.15 moles per 1 liter. Whenever I see that capital M, that's my conversion factor. Now I'm going to look and see if I can find my known. Oh, there it is. It's the only other number that's in this question. My unknown is going to be how many grams. Grams? Oh no! I'm going to have to grab my periodic table to calculate the molar mass, but we're going to start this problem off just the way it is. I'm going to start with my known, 1.25 liters. Liters on the top, I'm going to need liters on the bottom. This conversion factor is going to go in just the way it's written. 1 liter, 0.15 moles. I'm not done yet because I got to get to grams. If I have moles on the top, I'm going to need moles on the bottom. So 1 mole is equal to how many grams? Oh shoot, I got to calculate this. So you guys should be very good at calculating molar mass by now, so I'm just going to give you this one. We've got 1 calcium, we've got 2 fluorine. You're going to find the molar masses for calcium and fluorine, multiply the fluorine by 2, blah, 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 blah. And you're going to get a molar mass of 78.08 grams per mole. So now the grams are going to go on the top. Is 78.08 grams. You put it in the magical calculator, and you're going to get 14.64. But how many significant figures do you need? This one has 3. This one has 2. Remember, you're always going to go with the lowest number of significant figures, so I have to go with 2, which means this is going to round to 15 grams. Put a box around it so it's pretty. On to number 6. This one's a little different. When we're reading this one, it says, what is the molarity of a solution that is made by adding 57.3 grams of magnesium oxide, MgO, to 500.0 milliliters of a solution? There's no conversion factor in this. In fact, that is my unknown. I have to figure out what the molarity is. So remember, the formula for molarity is the number of moles by 1 liter. So divided by the liters. So let's start to figure out how many moles we have. We have 57.3 grams of MgO. So if I've got G for grams, G stands for grab your periodic table. I'm going to have grams down here, and I'm going to have mole up there. Of course, it's going to be 1 mole, and I got to calculate the molar mass. We've got 1 magnesium, we've got 1 oxygen. You'd find the molar masses, add them together, and you're going to find that the molar mass for this compound is 40.30 grams per mole. So 40.30 grams is going to go here. Put it in your calculator to find out how many moles there are, and it's 1.42 moles. So I'm halfway done. I figured out how many moles I've got, and now I got to find out how many liters. But check this out. This volume is in milliliters, so I got to convert that to liters. So I'm going to start with my known, 500.0 milliliters. Got to have milliliters on the bottom, and I'm going to have liter on the top. So then you're going to look to see, or you should maybe know already, that a milliliter would be 1,000 milliliters to 1 liter. So we're going to put that in the calculator, and the answer you're going to get is 0.5000. Now, I got to leave those zeros there because that gives me my significant figures. Now I'm ready to plug these numbers into my formula. So the number of moles in this are 1.42 moles divided by my number of liters, my volume, 0.5123 liters. Put that in the magic calculator, and you're going to get 2.84 molarity. 3 significant figures, because that has 3, this has 4. I got to go with the lower one, and there's your answer. Number 7, right there. How many milliliter of a 0.60 molarity solution would contain 12 grams of aluminum nitrate? Aluminum nitrate. So first thing, I'm going to scan this, see if I can find a conversion factor. Oop, there it is. 0.63 moles per 1 liter of my solution. This would be your known, and I got to convert this to milliliters. So I'm going to start my problem. I'm going to start with my known, 12 grams. I have 12 grams, I got to grab my periodic table. I'm going to calculate the molar mass. Aluminum, I've got 1 of them. Nitrogen, 3 is on the outside of that, so I'm going to have 3 nitrogen. I'm going to multiply 3 times the oxygen, so that's going to be oxygen of 9. 3 times 3 is 9. Look up the masses for oxygen, nitrogen, and aluminum, and when you total all those up, you're going to find that your molar mass is 213.01. You heard it. You heard it. She's going to say it again. Grams per mole. Now, back to my factor label. I've got 12 grams on the top. 213.01 grams is going to go on the bottom. Grams per mole. Grams per 1 mole. Always with 1 with the mole. Be at 1 with the mole. Now I've got mole on the top. I'm not to milliliters left yet. So I'm going to put 1. Whoop, let me back up here. I'm using my conversion factor. So now I've got mole on the top. I need to match that unit. And now I'm going to get my molarity conversion factor. So 0.63 moles to 1 liter. Not quite done yet because I have to have my answer in milliliters. I got liter on the top. I'm going to have liter on the bottom. And I'm going to be milliliters on the top of this. 1 liter is equal to 1,000 milliliters. Now I'm to milliliters, and I can stop my problem, and I can calculate my answer. You put that in the calculator, and you're going to get 89 milliliters. And there it is. So now you can try this one on your own. You've got that on your paper. The correct answer that you should get with the right number of significant figures is 330 grams. So go ahead and calculate this for yourself, and that's the answer you should get. Bye.